Hey there guys, and welcome back. So, I teased this one last weekend, didn't get around to it last weekend, but we will be making attachments add-ons for my Carvera. Carvera, in case you are unaware, is a desktop CNC milling machine, vertical milling machine. I do have all the accessories that would come with it. One of the things I did the Kickstarter, got one of them for free, and well, free, and then got the ended up paying for the other one, so that would be the CNC kit and the fourth axis one. That's the setup running. The add-ons that I'm looking to do today. First off, this is the arm that goes on the side. This is a phone/tablet holder. I probably in the future will replace this with something else on this ball joint because I'm not using this tablet/phone holder. I don't have anything to use it with. So that may be an add-on in the future, but I bring this up because I figured the space right here, this little slot right here, I can go ahead and store the bits that are currently in the machine. I can make a little holder and store the bits that are currently loaded in the machine in the order they're loaded in. Because, you know, remembering what is exactly in the machine is, you know, a little bit of a pain in the butt. Obviously, I could have like a whiteboard or something like that, but I figured this makes more sense because I'm going to have empty, or I do have rather, empty bit holders just laying around. I was keeping them underneath the machine, but they got knocked around a couple times. So, up and out of the way makes sense. This is on the right-hand side of my machine right now, and assuming that I need to fold it up, I think that means that I'm best off putting them on this side. That way it can fold inwards. If I put them on the back side, then obviously that can't. So that is the plan there. That's add-on number 1. Add-on number 2 is for the opposite side. So this is the blank that would go on the opposite side. There's the same exact mounting pattern on each side for attachments. I ended up putting this phone holder on the right-hand side because that made more sense for my setup. On the right-hand side, I'm going to replace this blank right here with a machined set with basically a duplicate of this. I'll fully cut out this notch right here for the USB hole. The USB holes honestly don't seem to be doing anything on my machine. I don't know why, but just in case I can use it in the future, I'll do that. Otherwise, what we will be making is a little, well, alright, I'm pretty sure what I want to do here is I want to go ahead and tap into my 2020 extrusion. Obviously, I've made plenty of projects with that. That seems to be the best bet for making a rack, or at least the most straightforward bet for making a rack. So I'm going to put little alignment tabs here and here on the duplicate of this that I'm making, and have a piece of 2020 upright going up and down on the machine. And then from that, I can go ahead and just attach other pieces of 2020 in order to make more holders. So that is number 2. Number 2 is a plate that I can align a piece of 2020 on. And from there, I'll figure out what else I want to make to attach to that 2020. And the third thing is just bit holders. So as I mentioned, I had the bits I'm using underneath the machine right now. There's space underneath the machine. A little bit higher than, a little bit more space. I don't have the exact number because I probably should have taken that down, but I figured it was enough. It was plenty of space without interfering with the Y gantry. So I can actually store stuff in there. I'm going to go ahead and store all my extra bits underneath the machine. I'm going to make puzzle pieces. That way I can just make a new puzzle piece every time I get a new set of bits. That's the idea. And then I can just slide that underneath the machine and, you know, like that. And then that will be up and out of the way. So those are the 3 add-ons I'm making for my machine. And yep, that's everything we need to know. For the bit holders up here, let's start talking about those. So I think I'm going to go ahead and just, I'm between having individual pieces and having a 6-piece rack. Okay. I didn't actually measure this. I assumed that it was long enough, but even if it's not long enough, from here to the elbow, or I could even go past the elbow, you know, if we need to go past the elbow, then all I got to do is raise the 3D print up a little bit. Oh, I should have said that. The bit holders will all be 3D printed. this replacement plate will be machined on the Carvera. For the record, 3D printing is cheaper and easier, and it's not going to have much wear on it. This replacement plate, however, is going to have a lot of weight on it. In theory, could have a lot of weight on it, I should say. So therefore, I'm going to make it out of aluminum, and I'm also going to I'm considering anodizing it like this piece is. That way it looks exactly like the piece that comes with it, and we'll go from there. For the record, now this is one of those funny things where I have the machine, therefore I want to do this from scratch. But in theory, what I could do instead of making a whole new piece is I could actually just drill out 2 holes here, making sure that I keep them in line, and then toss some bolts through here. Maybe thread it so that the bolts are in, and then thread locker it so that the bolts don't come out. And those 2 bolts could just hold the extrusion vertically. T-nut it, rather, is what I should say, bolts and T-nuts. That was the other idea I had. I am going to have to put a bolt hole in this, I forgot, in order to actually keep the extrusion from going up and down. The reason I forgot that, and I didn't mention it the first time, is actually I was thinking of not doing that. Instead of fastening the T extrusion to the plate, I was actually considering just making the whole entire extrusion long enough so that it hits my bench, goes down to the bottom, and just rests on the ground. And then these 2 alignment things are just keeping it from flopping left and right. So that's why I didn't mention this before. But even if I did that, I realized, point being, is that I still need something to keep it up against the machine and not falling back outwards. So that is piece number 2, the particulars on that piece. And then I don't think I have to really go into detail on this, just little puzzle pieces that stick together, whatever size they need to be to match the bits that I'm putting under there. So that's easy enough. So those are the particulars. Really quick, I'm going to go ahead and, actually, I usually use red all the time, but the red is going to end up being the first one dead, so we'll use a different color today. We'll go ahead and get some numbers really quick. That way we have them down. So, arm is... let's see, that's just shy of 89, it looks like. No, it's like exactly 89. Okay. So, the arm here, 89. And let's see here. I wonder if this is tapered. So, 1216. 1216-ish. Alright, so we're going to call that 1216. This plate, again, one of those things. This plate, I really could save myself the effort and just drill through and put some alignment pins and the attachment bolt in here. But because I have the machine, I feel like using it. So 82 3/4. Yeah, you know what? Well, I'm playing with colors. Let's make each one a different color. And I'll have to figure out these the radius on these guys, because it does fit its radius on the outside as well. Like the machine is radius, the pocket this fits in is radius. So I'll have to figure out this radius, but I'm going to leave that for a minute. And we said 82 3/4 and 45 3/4. I should move that over here. 2 3/4, 45. That is 3/4. 45 3/4. Okie dokies. And then these guys, the bits. Grab a different color. Purple. So we have, all right, so for the ones that go on here, I think I'm going to just make one spring-loaded size, because all these are very close in size. I mean, I'll get exact measurement here just to prove the point. This is, for the record, the 1/8 inch bits that come with the machine are in this size box. This is a Speed Tiger bit, and this is 1/8 inch. It's rectangular for whatever reason. I'm not entirely sure. But it is about the same width as this guy is square. This is a 1/4 inch holder. This guy is just a skinnier version of the 1/4 inch holder. So, for the record, just so we know how close they are, that's like 12.3. Actually, it's funny because it's not coming up exactly square, which is a little interesting, but 12.25, let's say, 13, and then 10.4, and then do 12 3/4 and 12 3/4. Yeah, so this guy's a little bit wider. So let's just take 13.5 as my largest. 13.5 as my largest size. And actually, is this also my... I wasn't paying attention. Yeah, 10.5 is my smallest size. 10.5 as my smallest size. So we'll make a spring loading action here that will go up to 13.5. And the minimum will be a little under 10.5. That way it still has tension in it. And then for this guy, because this guy is going to be underneath. Now, for the record, that does make a little bit of a conundrum. I'm not sure what exactly I'll do with this when I take one of these bits out. Fact of the matter is that this guy right here and this guy are both broken bits. I've broken both of these bits so far. Good me. You know, so I can just toss the bits out and toss them into here. Just take a permanent marker and then write on it the new size. So I could do that. I could keep these broken containers around and then just move this into there and mark what the size is. So that's an option for when they go up on here. Just make sure I said that clearly. Otherwise, we got 88.29. And 53.1. And let me just check the height difference here. All right, so there is a bit of a height difference. So one of those things, again, when they go underneath the machine, they're going to all be going like this probably, although I may decide to turn it this way for these guys so that this is more square. So that's what I was checking here. Chances are, because this is so much taller going this way, in order to keep the puzzle pieces relatively the same size, they don't have to be. There's really no need for them to be the same size. But in order to keep them relatively the same size, it's probably better to line up individual bits in this direction. Just, again, to keep it a little bit more square. Uniform, I should say. Not really square, but uniform. Alright. So, that is all the numbers we need to get started. If I decide I need any more numbers, I will go ahead and figure them out at the time. Otherwise, let us get over to Fusion. Fusion. There we go. Right. Markers put away, and calipers closed and off. Oh. Yep. That's the one more thing that I meant to take down here. I just realized. Yeah, these are M4s. That's funny. They're not quite M4s. Where's my M4s? 1 second. Let me pull that. I just kind of looked at them and assumed they were M4s. But, yeah, alright, M4 should be right about 4mm, so I'm not going crazy about that. These are a good 0.15 under 4mm, so they're a little small. I can still make the whole 4mm, which is what my plan was. But, it's a good thing I checked that. Well, I guess it's not necessarily, it doesn't necessarily matter if I'm just getting to ignore my number. The only other thing I need to check, though, is what the countersink is on this plate. The countersink on the plate is Oh, actually, you know what? I lied. Let's see. Back to camera. Alright, so... I forgot. I also need hole spacing. That would be very helpful. So, we have... about 61.9 to the outside minus 70.2. Yeah, 70.2. So, calculator 70.2. I can 70.2 minus 69 is what I said. Was it? Nope, 61. 61.9. That's where the 9 was. Alright, so 8.3 in half divided by 2 is 4.15 plus... That doesn't sound right. Does it? I guess it does. 61.9. So 66 millimeters between holes. I guess red. Christmas. 66. And the holes are just in center. And actually, I should also get this guy. Went a little quick and probably should have slowed down. I'm pretty sure this is centered. Let's do a quick check. So that is 29. That's funny. I'm slipping off that side. 29. So 29. And I just foobarred that one. That looks like 82 3/4. Yes, it was. Okay. 82. And the depth on this guy is 10.3. 10.3. All right. There we go. Now we actually have all the things we need. Actually, countersinks. I forgot the countersinks. Again. All right, 1.9. Okay. Now, for fusion for real. Fusion for real. Alright. So, first off, just mock up this arm really quick. Actually, new component. There we go. Arm. Just a rough markup for the time being. No need to get fancy. And the outside does not necessarily matter, but especially because it's off center. The hole is actually off center on this by 8.3 something, 6.5 ish. So like an inch and what is that? 0.8 or something like that. Not gonna do math on stream. So regardless, it doesn't necessarily matter that it's off center was my entire point. Just 27 on the outside is all that really matters. 27, and then we already had down that the inside. And technically speaking, This is also off-centered. And the off-center actually kind of does matter for this one. So I will take this down as 31.2. 31.2. The width here was 89. The height here was 12.16. And we actually are going to, I guess I'll just drop that on center. Do that. Should be fine. Funny thing is that actually looks off center now, which is funny. Okay, it's not off center by much. Okay, anyway. So I had 31, and then on the opposite side, I had, or I guess I should just take the overall length. Would make more sense. Kind of assumed my calipers weren't going to reach, but it looks like they do. 132, at least close enough. 132, again, doesn't have to be exact because we aren't exactly doing exactly. And the thickness is, oh, actually, if you look at that, back to it looked like it was going to go off center, I was saying. I was trying to avoid sticking another center line in here, was the point. I, technically speaking, don't have to. I could actually go ahead and just take this measurement here. Which is 6.5. And just toss it in here. Then we can delete that line. Okie dokies. Thickness is 6.5. Okay. And actually, I'm going to swap that to be on center. Overall distance. Okay. 2. Alright, now onto that holder. Now, again, I was thinking about just having one full sleeve and then putting the individual holders in there. Which, yeah, I think that still makes sense to me. So let's go ahead and get that up and in here. The other thing is if we come back to the camera really quick, this ball joint obviously does take away some of our space on the inside here, but not really until it folds all the way up. And the fact of the matter is that because of the way this is working, it doesn't even need to. Yeah, okay. So I guess that doesn't necessarily matter. I think we're safe. Yeah, I'm going to say we're safe. I was trying to figure out how much extra space I had to put in there to accommodate the space taken inside here when this folds over, but as you can see, it can fold up with the ball joint pointing towards the outside, so that's not actually going to be a factor. So we are good. Back to Fusion, and let's get to drawing. Do I want to do a top view? Do I want to do a side view? I think I'm going to do a side view. Yeah, I'm going to do a side view. I was just, I'm just sanity checking that this is the front, that is the right-hand side. I just want to make sure I had my orientation correct when I did that arm, because I was not necessarily paying attention. Alright, so toss that in there. And I am on the paint tool for whatever reason. Wish Fusion would get rid of that tool. Alright, so we're just going to toss some clips in here so I can just clip it in. The bits are pretty light, so I feel comfortable just using a clip in here. And chances are I'm not even going to make the clip in continuous across the width of it. I'm probably just going to do clips at the ends. So that is that. I already have this. Yes, do. We can just make this like 4mm. That's fine. Toss a little point in. And do that. Do a trapezoid. That way you have a little bit of leeway. We can call this whatever we would like. Doesn't necessarily matter. And the height here should probably only be like 2mm. Unless that's not going to work. There we go. 0.5. Okie dokies. And for the thickness, probably like 3 or 4. 3, let's call it. And out the front for the clips. Why are you stuck? Why aren't you moving? There we go. Let's see. So at the end, and we're jumping back and forth between the camera a bunch. As you can see, this is a ball on the end because they threw the bolt through here. If we need to go past the end here, that means we need to get above the ball right here. So I'm going to go ahead and take that into consideration. And we're at about 12mm right here. And I said this was 6.5. I'm actually getting just 6 right now, which is fascinating. So we're going to have to fix that. I don't know how terrible I am with calipers, but it is what it is. So that just means that we need to go a little over 3mm to get past this, right? Because the 6.5 is 3, the 12.5 is 6, the 6 minus 3 is 3, so a little bit more than 3mm to get past this. Technically, it should be right on 3mm, but we're giving ourselves a little bit of hair room. So let's call it 3.5. Let's call it 4. Alright. Scrolling back here. That should just be 6mm. Okay. There we go. And we can go ahead and just mirror this over the top, so that's no problem. And, whoops, I'm not in the drawing. There we go. Then, let's see. Yeah. Just put this right here, the linear, and this is just going to be a area for the individual bit holders to clip into. And to connect the two pieces, I should say. And to connect. The only thing I'm thinking here, there's a couple things I'm thinking. This doesn't have to be that thick. I think I'm going to leave it, no, I'll leave it at 4mm. That way I can do 2 for countersink when we do the individual bit holders, and 2mm otherwise, past the countersink. But now that we have this offset here, where this needs to extend out past the ball that's on the end, I should toss another alignment feature in here, just so that it doesn't rock back. So we'll provide a little bit of offset here. 0.5mm. You know what, actually? Quarter's fine. And then this can be really whatever at the end of the day. 2. And all this should be getting printed on its side. So it really doesn't matter what this degree is. This angle is right here. All this should be printed up and down. That does mean that if we don't run continuous with these clips, then I will need support in there unless, yeah, yeah, not necessarily. So if we make this 60 right here, I mean, That is actually... Nah, that's fine. Technically speaking, that's not even 60. Technically speaking. Or not the 60 I wanted, rather. 60 I wanted was right here. I'm going to back it off to 50 because we do have this dead space back here that's not being used. So we can afford it. There's nothing stopping us. So that's going to be a 50-degree overhang, which is no big deal. This is obviously significantly less than 50 right here. And I'll just add some support right here. Just paint in some support to handle that. Oh my goodness. All right, I took a several-month break, okay, from streaming. And, all right, I'm going to have to relearn to switch my scenes back and forth. So what we just did right there, as I mentioned, was we made this front part right here at 4mm. That way I can countersink in here the back of the bit holder, and then the front of the bit holder goes like this through the piece. And then I threw this guy in right here. And this little guy right here, as you can see, is just to stop this from sinking further into the hole, into the slot. Okay. I am actually more happy that I did not make that mistake last stream, on my first stream back. Forgetting to switch back and forth. So, that is everything we need for this piece. So let us get it extruded. I'm going to start with this piece right here, I think. Let's consider really quick. I have 6 slots, 6 tool slots in the machine. And my maximum was 13.5, it looks like. I accidentally erased it, but that's okay. We can always remeasure again. Speed Tiger ones, 13.3, 4, something like that. I'm going to call it 13.5. Just because. 13.5. Okay. Fixed, and snapping my markers back in. All right. So 13.5 times 6. Calculator. 13.5 times 6 is 81. And our gap in there, let's check that really quick. What was that? Our gap is 89. So if our gap is 89, calculator, 89 minus 81 means that I have 8mm of space in between. Divided by 6 is very little. So that's not really enough, which means that the bits will have to hang out over. This is the back right now. So the front side, there we go. Right hand side, we have the 31.2 on that side, and that is 12 to here. This is in theory 12 right here where the bolt comes. So between that we have another 19.2 millimeters of space, which is a lot more. So we were at 8 millimeters. 8 millimeters plus 19, right, is 27. 27 divided by 6 is 4 millimeters of space, which is good-ish. It's not actually that good for the design I'm looking to do. It's not actually enough. So we actually will be extending out over the edge then. Unless we also come this way, which we probably shouldn't, because again, the ball hinge is right here, and I want to keep away from the ball hinge. The pivot hinge, whatever. The pivot hinge where the ball joint is. So it does look like we'll be extending out like this further. And in that case, I should probably just extrude the clips right now, so we have some reference. And then I will design the bit holder. I will array that out, and then I will use that to determine how far out I need to go. Okay, cool. Sounds good to me. Huh. Interesting. Where is that? Right here? Huh. There we go. For some reason, I thought there was a right click option to remove things from the bar. All right, so just extruding the tabs for right now. From object. There. Yes, we are in front. So, let's make them like 10 millimeters. I'm probably okay with that. And then we will just join them up later. From object. Oops. Spin me round, right around. All right, cool. And I won't worry about mirroring those down just yet until we get the bit holders set up. Create new component, bit holder, and from here, yeah, I should probably design it top down. Okay. Let's see. We're still front, right? So I want to design them. I want them starting from right here. So I'm going to take this as a reference. That way I can start my array naturally rather than having to fudge it. All right, turn that off, turn that off. Actually, I probably shouldn't have called this bit holder. Or one of these should not be bit holder. This actually does make sense as bit holder. It's a minor predicament. So let's see, I need between 10.5 and 13.5 on these bits. My plan was, I didn't really go over this. We're going to attempt to not forget to switch back from the camera this time. But my plan on the bit holder was to have them vertically. So the bit holders, the bits plug into the bit holders like this. And the springs are like this. And then obviously from the front and back as well. So that's the layout. I was going with that. You know what? It's one of these things. It only just occurred to me. Let's see if we can mirror this video feed. That way you have it right side up. I'm not entirely sure why I never thought to do this before. This is a good-ish idea. Funny thing is that, okay, you know what? I'm gonna slide this up here then. Not on them doing this. Wait, is that upside down? Alright. Real talk, my eyes don't work. All these numbers are upside down still, right? Did I not just mirror this? Upside down. Upside down? Backwards? There we go. Huh. Why did I have to flip it both directions? Okay, whatever. Okay. Now you can read everything. That's fine. That's fine. Alright. So anyway, bit holder is going to go like this. That way I just slide it down into it. And in theory, this can even slide all the way through. These springs out the bottom. It's one of those things where being able to read the label matters. So I kind of don't want to do more than just a little bit at the bottom. That way the label is still visible. And The other option, obviously, would be to clip in from the back, just like these guys were made. There's two reasons why I don't think I want to go with that. And the first one is that these markers are all uniform size. So the same exact clip works for everything. While I can swap out these clips, I designed these clips so that they can be replaced if necessary. I could do the same thing with the bit holder, but that's just extra work and doesn't necessarily make sense to me. So instead, I am doing it in the bottom. And while I will leave the bottom open so that they can slide all the way through, I will just have to make sure to be safe and not slide them all the way. Yeah, I mean, that's basically it. It's not really worth talking about any other options with it, just because it's not going to happen. The side view of this is going to look like this. And this is just from the outside because the... Because... it just occurred to me, sorry, that on this design, as you can see, no, you can't see because it's black, but we got a bit of a clip-in on the front side. Actually, you know what? Let me just pull it up in Fusion. We designed these on stream, as you may recall, and we put a little retainer clip, just like this part right here. We had a little retainer clip. Miscellaneous markers. Hopefully I am sorted by date. Okay, yeah, looks like we're sorted by date. So, as you may recall, there we go, the marker holders we did on stream. They got a little clip in, just like I was designing there, so they stay in. With the ones that we're going to be making here, because the holder is square, the holder that I'm designing is square and not open, I'm not exactly sure how that's going to work. It may make sense, instead of sliding these through like we did with these, where they slide in through the back and then clip in, which was my original concept. It may be that instead we design this. So this is the bar that holds them, and we design slots in them and just slide them straight down into the slot, especially because the bit is going to just be sitting straight up and down in there. So that probably makes more sense, because again, we're using this square side, so we don't really have the option to put a little clip in right here in order to go into the board. This is the board, and then this is the countersink right here that we had designed. So since we can't do that, it probably makes more sense to just slide down into the piece. Okay, back to Fusion. All right. So, that being the case, we are in the top view right now. And that means that... this is our design right here. Oh yeah, actually I should extrude that. I mean, not extrude. Project that out as well. So that is the thing we're feeding into right there. And that means, now since we're gonna have to go past the joint at the end here, I may actually need to bump that out a little bit more than I did. Nah, actually I don't. Yeah. Since we're just sliding in, all right. I just need to readjust my mind to make sense here. So, since we are doing that, we'll just put a dovetail joint in here. That makes sense to me. Change this to being parallel to that. parallel to that, and coinkydink with that. There we go. And then we'll go ahead and leave this 2 millimeters from the edge, because again, our board is going to start on this side and go out past that side. So we can leave 2 millimeters of space on the edge there. And then we just make these. Let's see, this joint should only be about 2 millimeters. Well, not about, because again, it should be. Actually, instead of doing that, I should grab the center point on that guy. And I will toss a construction line in there and just have that construction line coinkydink with that. That way it's always in the center. The dovetail always stops in the center. And these are going to be printed up and down, so this angle doesn't necessarily matter. So we'll just make that a 45. And one of those things may as well make it a, there we go, a half view, and just mirror the body over, since it's going to be symmetric. And in that case, we can just coinkydink that with, please. Oh, duh, that is why. Instead of doing that, we'll do that. Makes sense. I am streaming much later than normal, for the record. I will take all the excuses I can get right now. So, our largest size, I'm going to toss it in as a construction, is 13.5 by 13.5. And that is, as you can see, quite large relative to the rest of this. That is where the spring needs to be, and the spring is going to be slightly smaller than the actual plastic itself. So let us roll that in. Honestly, it only really needs like 0.5, because that's the absolute biggest we want to go. So it really doesn't need that much. And for the record, because it's been a while, I tend to do this, label these offsets individually rather than using the offset tool, because the offset tool tends to break a lot, I have found, when I need to adjust things. So for the record, that is why. Let's see, this guy maybe should go just a hair. I'm gonna put him just a hair, just like 0.2 ahead of the edge of this backing plate. And I'm doing that because I really don't want it to collide. Oh, that's the other thing I was gonna do. Oh no, that's right. We're good. We're good. Never mind. I take it back. I take it back. Although, I just realized I didn't put the rest of the plastic in, because I need an outline here. Alright. So let's get that set up really quick. Let's say just 2 millimeters, because it's not really doing anything. Just kind of making sure everything stays in place. Millimeters. Alright, now we can go back there. And toss that 0.2 back in. And then we can very simply connect that to there. And again, this is going to go center to that. And this can be any distance we want. So let's define this relative to that. Let's just call it 1. Okay. And this dovetail joint is rather beefy, but that's going to be okay. You know what? Let us undo that, and just drag you all the way down to the other side. Midpoint of there. There we go. All right, cool. Cool. So, let's bring this guy and this guy back up. This to so. Back to camera really quick. These bits, they can kind of sit in a range here. In theory, they shouldn't really sit lower than. Let me try to get my hand out of the way here so you can see. Shouldn't really fit lower than this bottom edge right here. They should sit probably a little bit higher. I mean, heck no. They could just be in line with this bottom edge. That would be fine. And the reason this comes up is just where I start extruding this from. Because, again, I'm only going to want to extrude maybe 10 millimeters. Because that's the max that we're going to be seeding these into, these bits into it. Is about 10 millimeters, it looks like. I can get you a more definite size. But 10 millimeters looks about right. That's like 9.5, so I'll call it 9 instead. Just again, that way I'm not covering up the label at all. So, we only need 10 millimeters. And we will be clipping top and bottom, so it's not like we can save much space anyway. I'm just trying to see how much plastic we can save. That's all I'm really doing. And seeing where I need to start extruding from. Yeah, I think I'll just extrude from the bottom. And call it a day. Back to Fusion. Close that now. Also that. You. And give me back my extrusion. So. Grab that arm again. From object. Oh, actually, that was the other reason. Because this is going to feed into, and we don't want this dovetail to drop out the bottom of the back plate, was the other reason. So I'm going to put a 3mm on here. 3mm offset. That way we still have a little bit of the back plate left on the bottom. And. Think I'm good with that. Actually, there is the other idea that I did not consider, which was doing the clips separate from the back plate. So kind of like how we're connecting all this stuff, and in the markers example, we had the press through on that. We could do the same thing here. Because as I'm printing, the reason I'm saying this is, let me just screw this out so that we can, all right, get back to the conversation. So again, these clips are designed to be printed on the ground like this, and one of my problems, oh no, that's right, I was going to print them this way. That's right. These could though, however, yeah. All right, so these clips are better off printed up and down like this, so that this is against the bed plate, the print bed, let's say that's against a print bed. They're better off like that because as you're looking down at it, you'll see that the opposite clip is on the same layer lines as this clip. So when it bends in this direction, it's bending on in the same axis as the well, not in the same axis as the layer lines. How am I saying this? It's bending perpendicular to the layer lines so that each layer line is bending the same amount, as opposed to if this was printed as I was originally planning to print it, which is, let me just hit the cube really quick. There we go, like this. So if I was going to print it like this, up and down like this, which was my original idea. That means that as it bent, the layer lines are actually technically shearing. So that's not ideal. Would it still work? Yeah, it would still work, honestly. But it would be better not to do that. So in the same idea that we have here, connecting here, I think I'm going to modify this so that these clips get printed separately and then clip into the front plate. And yeah, and that should be good. All right, so we'll make that modification in a minute. Let's get this guy finished. So let us mirror that body across that face. There we go. Huh. Why you got a weird join line on? You're still one body, right? Yes. Huh. Alright, whatever. Should be fine. Alright, now to draw the springs. And I will draw them in this orientation. Project. Yeah, see, that's obnoxious. Why are you doing this to me? Whatever. Okay. Look. Body off. Body off. And we will just draw in our 1mm line. Our 1mm line. And our, what's our difference here? Exactly 3mm. All right. Although it's 1.5mm per side. How much space did I give myself 1mm? I know it's been like 5 minutes, but 1 second. I only give myself 0.5mm. Okay. 0.5. There we go. There's my 0.5. And this is my 1.5. 1.5. Alright, cool. And now I'm just going to toss a spline in here. And oh, this is my 10mm right here. Yep. It's just occurring to me that this is a very long, this is a lot longer than the other one I did. So what, for the record, what I'm using for reference here, my other design that I did that did a similar thing was these guys right here, which I just scrolled past. Doink. There we go. And turn that off. Turn the, oh, that one. So these guys. So you can see I did these little flex things right here, and I did them one piece. You know what? Maybe I did a second one that was individual springs somewhere down here. I know I have another design where it was individual springs. Oh, that's what it was. It was a very old design, actually. This one is just cones. This is a little bit different, though, because these are mandrel openings. So they actually are fine being a bit stiffer. But probably gonna be okay. Anyway, if it doesn't work, I'll cry about it. The springs are gonna go this way, and I guess I will use this while we're here. Where's my checkmark button? Fusion? Checkmark button? Okay, good enough. So 50. Let's call this 30. Or not 30. I want to go the other way. Which way? That's the way I wanted. That's the way I wanted. And this guy should be parallel. Then we just gotta mess with this to make this look a little bit. Yeah, maybe 20 was overdoing it. Let's see. Yeah, I might have been a bit too aggressive here. What it's looking like. Let's just roll all the way back and start back from the natural curve. See, I kind of want to make it a little bit more drastic is just the thing. I probably don't need this second edit, the second spline point right here. Where is remove? I see delete coincidence, but where is remove spline point? I don't see one. Delete. Delete. There we go. All right. Let's just go with the one then. All right. Yeah. For the size here, that is actually not going to work. But basically, relative to this 1.5, the way I wanted to do it, the way I was visualizing it, is a bit difficult to actually fit into here. Not least among which is that the piece of plastic I put in here for the spring leaf is actually going to be about the same size as this 1.5 gap that we have. I just realized. So we are going to do this a little differently. And the way we are going to do this differently is I'm probably better off. See, it's tough. It's actually tough because of the orientation that this is going to be printed in. Is the problem I'm running into right now. So this wants to be printed up and down like this. These individual springs kind of want to be printed on edge for the same reason that I mentioned earlier about the clips on the back. I figured it doesn't necessarily matter if they're printed up and down because they're not flexing that much, was my idea. What I am thinking now is that I might go ahead and cut a window out to give myself more room to spring in. Because the fact of the matter is that each of the springs, I can't really print them individually. I don't think I can at any rate. Because they're a bit difficult to actually get in there, given the size limitations and the precision I can get with a FDM printer. So, for that reason, We might be changing tack here. Yeah, all right. All right, all right, all right. We are changing tack. I am going to default to, I think. Does this make sense? So I'm considering changing this. Let's go ahead and hop over to camera really quick. Changing this from a flat plate to actually slots with, and use a rubber band just to keep everything up. I mean, heck, it doesn't even need to be a rubber band. It could just be slots to begin with. So while I like this idea of having everything snug, you know, and it's really satisfying to click these things in and out. Well, that's all nice and dandy and all. It's a little bit unnecessary because literally nothing is moving. These guys are going to sit up and down and not move at all. So we could instead make a very simple shape like this, right? Have a floor on the bottom, have the bits sitting in here, and then just have a little attachment point for a rubber band just as a fence to keep everything from falling out, right? And the height of this at that point, because these are open front faced, then can be the whole entire height of this. Well, not the whole entire height, but it can be, for example, the whole entire height of the arm right here. Yeah. I am not, aside from, again, this stuff being real satisfying, aside from this stuff being real satisfying, I am not seeing any other good explanation for why we need to go this far to get these guys, you know, spring locked into position. And I think we are going to just default back onto this. Point being. So that is the new plan. So let us come back up here. Roll back over here. Delete all features after this. And let's see, this is my side view. This can now honestly be 2. Because all it is just a back. Although, we may not. Only because, again, I want to switch these clips up to actually clip in. So. Now I'm thinking, so the difference here, is there much of a difference? Nah, there's not much of a difference. Never mind. I take it back. Thinking about the clips, I was thinking about whether or not it really matters. So back to this plate, now these clips are going into the plate, which means that this plate is, instead of linear, it's going to be a bit higher in order for these guys to sit behind it. We're going to need another one right here. for it to back up against. Actually, that is backwards, isn't it? Okay. 1.5. 0.5 is all really. And then we need to toss a line all the way through. Yeah, right? Yes. Yes. To do that. You know what? I'm gonna already have this line here, so toss this line in here first. So linear, linear, and then we'll toss that line back in between there. And this is 2 millimeters. Okay. And this does just go to there. And another one right here. That should not be like that. That should be perpendicular and quinkadink. Okay. So grab those things now. Grab those things now. Got that. Yes. Okay. Turn the body back on really quick. Did I not hit okay? Just a quick sanity check. Yeah, I think I'm fine. These guys on those guys. Join. No weird center join. Good. It just occurred to me that on these guys, yeah, these guys have the back flange on them as well. So let's fix this really quick. So there's that, and then we also have this as well. Divided by 2. That is collinear. And this hangs over by like 2 or 1. 1 is fine. I'm happy with 1. Okay. Finish. Correct that stuff. And I see we made a mistake here. I made a mistake here. This, yes. Okay. Try this again. That. Okay. And that. Okay. Why does it keep on missing pieces? I keep on missing pieces, I guess. That would be a reason. Alright. Alright. Everything looked good, I think. I think so. I think we're all right. So these guys, I will now that these are their own object, we're just going to really quick transfer them. Flip. Flip. And then we'll do the back plate now, which actually is still this object right here. Yeah, from the top. Project this. Okie dokies. And turn the arm off. We also need that guy as before. That. So that is our whole entire back wall. That is 2 millimeters, which is fine for a back wall. And we will not go the full 13.5 or the 10.5. We'll go like 9, let's say. We quinky dink that. We toss this in here. Get rid of that. That parallel. Quinky dink that just because we have it. Otherwise, we do 2 millimeters over here as well. 2 millimeters. 2 millimeters. And then this honestly can go all the way to the front. I'm feeling pretty comfortable about that. Make that 9 millimeters. This should stop there. And let's see. I guess what I should do, let's make that 1 millimeter right there. And call that 13, 14. Call that 14. And I will extrude this out and then pattern it down. And then we will add the rest. That makes sense to me. All right, cool. So, buddies. Oh, I only have the clips. That's why. Let's grab the arm. Let's see. Consider. From object, we'll use this sketch right here. We will not use that sketch right there. Yeah, we will not use that sketch right here. So we will go, because these are mirrored, we can go there, -1. Oh, I meant to do -1 here. And -2 is what I wanted. And we can go 2 directions. Oh, yes, that makes sense there too. And then 2 object. There. And 1. I guess that makes sense. I'm gonna have that hole there. We'll see how that ends up over here, but I should fix this one over here. All right, we'll start there. We'll fix our sketch really quick here so that we're not overlapping that. So see. That clip is at the very end. So that clip's actually going to have to move. Let's do that. Let's fix that then. The clip itself is the thing that is wrong. So the offset here of, let's call it 2.5. And now that is on the inside. So now I can actually out. So I'm going to pattern first though. We will pattern first. Pattern, line, bodies, correct. Object is that guy. Path is that guy. I actually should figure out what this actually is. So 14, 2, and 1. Or no, 14 and 1. 14 and 2. Finish. Pattern. Body. Path. That guy. Start point 0. Distance 16. Spacing. I went in spacing. 16. Yes. Correct. Pretty sure that's correct. That looks correct to me. And we need 6 of these. And as it turns out, we actually don't get that far off now that I'm doing this way. So, this thing. Oh, that's right. I can't automatically join on this. So, before I do that, what else I want to do is double check this. Right. Okay. So I wanted to put our floor in, was the other thing I wanted to do. And this is just going to be from down here because I already include my 2 millimeters. Like that. Okay, cool. Good deal. Although that is now below, which means I need to fix that. And we'll fix that by doing that. Double check if I got that correct. Yeah, okay, I got that correct. So instead of that -1, do 1. There we go. And on the top here, I want 2 millimeters there. Okay. Much better. Okay. Back to where we're at. Now we join all these corrosives. There. Okay. This guy is off. So let us consider how we want to handle this. We don't necessarily want to screw around with the spacing here in front. So what I will actually do is I will undo this over here. Just this guy. We'll hop in here, delete that, hop in here, move that guy down to here. I'm gonna go ahead and change this to clips now, and then hop in here to do this. Turn the body off really quick. Turn the arm off. You guys. And now, since we are at the end, we can go from object. I guess I'll do this wall. Give ourselves a millimeter offset. And we had 10 millimeters on the clip just to keep it identical to the other one. And, yeah, you know what? We'll just do the one component instead of splitting it into 2 components. Mirror this guy up. Join. And are good to go. Okay, or good to continue at any rate. Combine these guys. Tools. Cut. That's it. Cut. Turn the clips off. Get rid of these things. I probably could have done this a little bit more elegantly, but that's okay. Or no, actually no. I'm not getting rid of those things. What happened here? How did I lose the bottom on that guy? What happened here? Why are my clips not the same size? Oh, I know why my clips are not the same size. Derp. I highlighted too many things. I thought I highlighted too many things. I did highlight too many things. Just the wrong thing. Actually, yeah, I should have both of those. Is there any reason? I don't think there is. I don't think there's any reason to have this panel right here, because we already have these tabs keeping it from sliding out. So let us actually come back here, select that as well. Same thing over here. Select that as well. And now we have gaps in there. All right, cool. So all I got to do is throw in the print offsets like I was going to do earlier, where I realized that I screwed up the clips. All good. All right, cool. Minus 0.2. It doesn't need to be that much. Nah, it doesn't need to be that much. It's 0.1. They're going in there. They're never coming out. I'm not sliding them in and out. All right, and now all we need to do is this is going to be printed on the back like this. This is how this is getting printed. So we will put a little hook right here for the rubber band. And I'll probably make it the full height, just so that, yeah, we got plenty of space in the back, obviously. And we actually can rock this back a bit if we want to, because we are yeah, we can move this back towards the arm a little bit, because we are not actually far enough to interfere with this now. I should This is a little bit ugly, and honestly, this is one of those things where let's do this 2mm finish, and that what you call it, that 16 that I had before, still make sure that this is 2mm here, but it gives me the 2mm. So anyway, as I was saying, we're not close enough to the edge here that we actually need this 4mm offset. So we'll go ahead and rock this back. So instead of defining this as 4mm between there and there, I will just go ahead and put a small gap between there and there. Is that necessary? So the only reason that really kind of is necessary is that this spoke right here, this 2mm spoke. Yeah, you know what? I'm going to just shrink that up. So one of those things, this bends the most out at the edge here. So this height back here is fine, but this is not going to pivot as much up here. So this really should be smaller. So I'm going to actually make that another 0.5 because all it's doing is stopping it from sliding back through the arm. And that way we have an easier time getting the clip through the hole in the back here. So that should be fine. Okay. And nothing really should have broke. Quick sanity check that one. Yeah, we're fine. Good. And finally, onto the rubber band. Please. Come back here. Stop running away. All right. Off, off. Off, and off. And for the hook, let's see. Yeah, it really doesn't need to be special. Yeah, I was trying to think if there's any reason to make it special. There is literally no reason to make it special. So, we are going to make it as simple as possible. Toss one of these in here. Hopefully I did not connect that. I didn't. Get a center. Actually, no. We don't even need a center line because I'm just going to do this. Toss another one in here. Make this parallel to that. Make this centered on that guy. Make this, let's call it 1mm. And you get to stay collinear with that. And for our thickness, we'll just make it 4. For the length, I do want it actually like more or less the most of the height here, so I'm going to just make this 2 right here. And that is that. Simplest hook in the world. Start with that one. From object that minus. That's my rope. Been a while. Rubber band thickness is about 6mm, so we'll make it 7mm just to make it flexible. Just quick sanity check. Yeah, so one of those deals where the rubber band is flexible. So for that reason, so I was just looking at it as the rubber band coming here and then running long ways across this on edge, but it's not really going to do that. It's going to twist, but that's fine. But if it's going to twist here, then it's kind of also going to want to twist right here, coming off this edge. And that's probably all right. It's probably not that big of a deal. Probably overcomplicating things. Don't think too hard. Leave this edge just in case it stays extra flat on that edge. And we should be fine. Okay. You know what? Instead of long clicking everything, I'm just going to turn the body off. From object, -3. Okay. And that is that. Kind of. I mean, I need to throw the one on the other edge, I guess. Let's go ahead and take a midplane. Since our midplane is no, I mean, since this thing is not centered on the origin. Mirror. Features. And the midplane. That was not all the features I needed. There we go. And you are now deeply confused. Identical. Okay. There we go. There we go, there we go, there we go. Flips go on like that. Turn the construction off. There's the arm. Add some colors. Aluminum. Oops. Stay on that side though. Stay docked over there. I want a gray anodized. Hey, you know what? Let's make it bead blasted. Plastic. Whoops. And where's those clips at? Just do this. Makes sense. Alrighty. And that is that for that piece. Alright, so it has been an hour and a half. I was planning on doing all these at once, but because I had stuff going on tonight, I started a lot later than I normally would do this. Well, stuff this afternoon and tonight. And B, it took me a lot longer to actually get this first one done than I was expecting. Although a lot of that was set up on the whiteboard, talking about everything. So that's my excuse for that one. So we are going to do part 2 tomorrow morning, tomorrow afternoon, one of the two. I'll figure it out. We'll get the rest of this done. This guy over here should be super easy, no big deal. This guy over here should be relatively easy, no big deal. Again, I really only need, my only hang up is I need to figure out these radii right here. Figure out what those actually are. But beyond that, you know, again, the piece here is simple enough. So we'll do those two things tomorrow, either morning or afternoon. I'll figure out when to schedule it. And once we have those two things done, then I will go ahead and start designing the actual, some actual attachments for the extrusion that we're going to put on here to polish that out. So that is everything from me. Thank you guys for watching, and I hope you have a wonderful day, great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.